Hello, my name is Antonio Stewart, and I will be doing this presentation on PolyScope, Multi-Policy Access Control, Analysis to Compute Authorized Attack Operations in Android Systems. Android has become the most dominant mobile OS platform worldwide, deployed by a large number of vendors across a wide variety of form factors, including phones, tablets, and wearables. With Android's increased integration into people's daily lives, Android needs to provide sufficient and appropriate assurances of platform integrity. Additionally, vendors must be able to extend the Android platform to support their custom functionality and yet maintain such assurances to their customers. Android's implementation of file system access control is one of the most important defenses for providing such assurances. What is PolyScope? PolyScope is a new Android access control analysis tool that computes the set of authorized attack operations for an Android system while overcoming the limitations. Prior research that performs multi-policy analysis only computes information flows for a current snapshot of the policies, which neither accounts for policy manipulations nor identifies the specific attack operations that could enable exploitation. Okay, now we have some examples of vulnerabilities. A recent vulnerability discovered in Android services uses the download provider, allows untrusted apps to gain access to privileged files. The download provider enables services to retrieve files on behalf of apps by URI specifying the location of a file. So in this picture that we have here, we can see an adversary provides path name to the victim as a URI to lure the victim to an adversary created symbolic link that the victim resolves to the target file, enabling the adversary to modify the file indirectly through the victim. Our access control policy. Our access control policy analysis attempt to solve three main problems to help identify vulnerabilities, but current approaches suffer from key limitations on each problem. The first problem in using access control policy analysis is to identify the adversaries who may benefit from exploitation of each subject. The second problem is to determine the permissions adversaries control to create integrity violations. The third problem is to compute the operations that an adversary may be authorized to employ to launch these attacks, which we call attack operations. So we then come to our design background. So the various access control techniques used by Android systems that are necessary to understand the PolyScope design. So we have C Android Mac, which stands for C Android Mandatory Access Control. We have Unix DAC, which stands for Unix Discretionary Access Control. And we have Android Permission System. And then lastly, we have Linux capabilities. So under C Android Mac, the C Android is a port of the C Linux or SE Linux mandatory access control system with additional support for Android mechanisms such as binder IPC. C Android supports three access control modules: type enforcement or TE, role-based access control or RBAC, and multi-level security or MLS. All these models are mandatory access control models in that they are defined by the system and are not intended to be modified by users or their programs. Then we have the Unix DAC. It's just a Unix discretionary access control. And we have Android permission system, which is used to control access to app or applications and service data. Android data or service providers enforce most Android permissions, but some Android permissions are mapped to DAC, or the discretionary access control supplementary groups, which are assigned to applications when the associated Android permission is granted. And as far as our Linux capabilities, they're used to control access to file system resources directly or indirectly. So we have a table here showing the evaluation of our impacts. And the two main factors that we have in here are Google devices and OEM devices. So this table summarizes the highlights of the evaluation for 9 fresh installs of Android releases, demonstrating the importance of computing per victim adversaries, permission expansion, and attack operations. This table shows the relative effort to vet Android releases for vulnerabilities using the output of prior analysis, output of past analysis, using the PolyScope's method for computing adversaries, and 2 new analyses performed by PolyScope that provide more accurate accounting of the threats victims may face. So we have integrity violations. Integrity violations are a tuple of resource, adversary and victim, where the adversary is authorized to modify the resource and the victim is authorized to use or read, write, and execute the resource. So our integrity violation classes, we have 3 of these classes, which are file IVs, which stands for file integrity violations. We have binding IVs and path name IVs. So our file IVs, they grant adversaries direct access to modify files and victims' use. They possibly lead victims to unexpected use of adversary controlled data, which means that the victim doesn't know um, some of the data that they're going to be using, what the data will actually do. And they further distinguish by the victim can read, write, or execute the IV file. So we then have the binding IVs, which binding IVs are a little bit different. They grant their adversaries the ability to modify name resolution of the file, so they can go in and they can change the names of these files, and the victims wouldn't know which the files are because they changed the names. So they enable adversaries to redirect victims to target files during name resolution, causing victims to operate on files chosen by the adversary. So they can change the name and the files that they have that they want the victim to execute. They can change the names of those files to be the files that the victim is going to be accustomed with using. And we have path name IVs, which enable adversaries to lure victims to the part of the file system that the adversary can modify. Okay, so these file integrity violations, the vulnerability may be possible if a subject uses the access that they have, read, write, or execute a file that can be modified by an adversary. Binding integrity violations, a vulnerability is possible if the subject may use a binding in resolving file name that adversaries can modify. So the adversary can change the names of these files, having the victim to inadvertently um, choose these files. Um, Path name integrity violations, their violations are binding integrity violations that are possible when a subject uses input from an adversary to build a file path name used in name resolution. So these are different integrity violations where the adversary can manipulate the data. So we have a table here of the summary of impact of PolyScope analysis. So this table summarizes the highlights of the evaluation of 9 fresh installs of Android releases. It demonstrates the importance of computing per victim adversaries, permission expansion, and attack operations. It shows the relative effort to vet Android releases for vulnerabilities using the output of prior analysis, output of a past analysis using PolyScope's method for computing adversaries, and the 2 new analyses performed by PolyScope, PolyScope IVs after expansion and PolyScope IVs with operations that provide a more accurate accounting of threats victims may face. The counts are shown in terms of subject-object pairs. For data flows, we sum the object that each subject is authorized to use. For integrity violations or IVs, we only count the data flows to objects that another subject classified as an adversary is authorized to do. The first row of this table lists the number of authorized data flows allowed by Android access control policies. This shows the analysis that only compute data flows. The second row in the table, it shows the number of data flows to consider can be reduced significantly by only considering those that cause integrity violations. Additionally, PolyScope provides 2 new analysis steps to detect threats more accurately. First, the third row of Table 2 shows the number of PolyScope IVs after expansion, each which shows the count for IVs found. So in our conclusion, the conclusion of Android devices are safe, but they do have vulnerabilities to them if certain applications for finding these vulnerabilities aren't utilized. The Polyscope, the results from the Polyscope test, it had a lot of different other tests and attack methods to combat this. And in conclusion, I read that Android uses a combination of file system access control mechanisms to assure its platform integrity. PolyScope, a policy analysis tool that reasons over Android mandatory C Android and discretionary Unix permissions access control policies. In addition to the other mechanisms, i.e., Android permissions, that influence file access control. The results of that study suggest that the access control policy changes introduced by OEMs do not sufficiently address the integrity violations for their featured additions.